Welcome to this lecture on parametric simulation campaign. Within this lecture, I will be going to present what does it mean to perform a parametric study, how it can support the design process and the possible benefits for deep renovation, how to set up a parametric study, and then, to conclude, I will be going to present an example of application within the Horizon 2020 project for our renew. So, what is a parametric simulation campaign? Given a building energy model, making a parametric study means running a set of parallel simulations, changing relevant parameters for comparing the impact on performance results. So this is a general explanation, but focusing on building renovation, the parameters can represent, as an example, different technical solutions to be applied on a building, as it is represented in the picture. So why we can consider a parametric study as strategic for planning a deep renovation? For several reasons. For example, because it allows to compare the performances of different technical solutions in order to drive the design. It's also relevant for the identification of multiple scenarios for assessing the performance of the renovation in general, also according to different boundary conditions such as an example, the climatic data. Consequently, it can support the decision-making process with consistent information and allow to increase the reliability of the results, also for preparing an effective business plan of the renovation. So, how to set up a parametric simulation campaign in the specific case of deep renovation? As a first step, we need to define which is the design objective. So, which are the performance parameters that we want to assess? As an example of possible parameters, we can consider energy saving, comfort, investment, or life cycle cost. Then, it is important to identify the input variables, also according to what we need to assess within the parametric study, and to define the variation intervals and the reference values. The next step of the process is to run in parallel the series of energy simulation through the used tool and to obtain the results. Then, analyzing the performances, it is important to understand which is the relation between the inputs and outputs and to find the input combination that most fits the design objective. And the input combination corresponds to the technical solution to be adopted. There are two big families of inputs that can be adopted as variables, also according to the objective of the simulation parametric campaign. On the one hand, we can have the technology features and the technology performances of the different solution sets to be installed. So, as an example, we can consider different envelope performances, such as insulation type, the thickness and the thermal properties in general. For the window system, we can consider the thermal transmittance and the G value of the glass, and also the thermal properties of the frame. And concerning the heating, ventilation and air conditioning system, we can consider different values for the efficiency of the system itself and the relative subsystem. Another group of inputs that can be adopted as variables are represented by the boundary conditions, that are possible factors that can have an impact on the building performances before and after renovation. The estimation of the impact can be done through a parametric simulation campaign, adopting as a variable, for example, the weather condition, like the external temperature or the incident solar radiation on the building surface, the set point temperature, so the target values to be set during winter and during summer, and the user behavior, meaning the proper use of the installed technologies after renovation. So now we have a general idea on how to perform a parametric simulation campaign. And let's conclude the lecture with a practical example from the Horizon 2020 project for RNU. Here, the objective of the simulation campaign was to compare the performances of the different technologies developed within the project and to identify the most suitable combination of technologies that are the renovation packages according to the specific renovation needs of different kind of residential buildings across Europe. Here on the right side of the slide, there is the building adopted as a reference. There is the building block simulated in a given climatic context. The variables that we identified for the analysis were the level of insulation of the envelope considered with the thermal transmittance, and we set two values, 0.1 and 0.2 watt per square meter Kelvin. The number of the facades insulated with the prefabricated elements, that is one of the key technology developed within RNU. In particular, 2 facades or 4 facades. 2 different types of glasses, again characterized with the thermal transmittance 1.24 and 0.61 watt per square meter Kelvin, and the presence of natural or mechanical ventilation. And in the case of mechanical ventilation, we considered a heat recovery efficiency of 70%. So, the analysis is based on the combinations for insulation and ventilation as presented by these key selected variables. And the objective was to define which is the best set of technologies to be installed. This last slide presents a sample of the results, and in particular the comparison of different technical solutions in terms of heating demand and comfort improvements in comparison to the baseline case, that is the red spot. From this chart that reports all the results for the different configurations shown before, it is possible to understand some issues. For example, that the mechanical ventilation has a significant impact, especially on the reduction of discomfort periods. Another important evidence is that all the configurations without the prefabricated facades, blue spots, present lower performances in comparison to the other variants, and that there are no significant differences comparing different levels of transmittance of the envelope. So, after these considerations, is it possible to say that this kind of results can provide a very useful support for the designers, highlighting which are the foreseen performances of each technology and facilitating the decision-making process. Therefore, I really encourage you to follow this strategy when planning a renovation, intervention, and in general when approaching the design. So that's all from my side, and I really would like to thank you for attending the lecture.